In this video, we're going to look at graphs that are linear and try to write a mathematical model that gives us the relationship between the two variables. So if you look at this graph, right, we've got y equals 8x plus 4. So on that graph, the 8 is called the slope. Okay, so this is in the form of y equals mx plus b, where m is the slope. Okay, so in this case, the slope is 8, and where y is called the y-intercept, where the graph intercepts the y-axis, and in this case, it intersects at 4. So what we want to do is write this not with y's and x's and m's and b's, but with actual variables and with numbers. So y, this is your y-axis. So the y-axis is temperature. Okay, and we want to include units for everything. So that's Fahrenheit equals, so I need the slope, which is 8. And I'm going to leave some room here to put some units in once I figure out what they are. And then times the x. Well, here's my x-axis, so I write what's there. Time the units of seconds plus the y-intercept, which is 4, and I'm going to need some units. Well, the units of the y-intercept, because it's intercepting the y-axis, are just the units on the y-axis. So that's going to be Fahrenheit. The units for the slope are a tiny bit more complicated, but not much. It's just delta y over delta x. So the units on the y-axis divided by the units on the x-axis. So the units for the slope are simply Fahrenheit over seconds. And this is your mathematical model. You could use this to answer questions about how changing time affects the temperature in whatever's happening in this graph. Here's another graph. There's some instrument reading that reads percentage, and we're changing the concentration of something, and the units are moles per liter. It doesn't really matter if you understand what the instrument reading is or what concentration is right now. We can still write our mathematical model. Okay, so the best fit line they gave us is y equals 9.7926 times x plus 0.1990. So that's your slope, and that's your y-intercept. So again, we're going to try to write our mathematical model. We'll start with y. So I just write what's on the y-axis. I'm just going to abbreviate a little bit, so I'm going to say the reading, and the units are percentage, equals the slope, which is this 9.7926. I'm going to leave room for some units, times, okay, x, so I'm going to write what's on the x-axis, and I'm going to abbreviate a little bit, so concentration, include the units, moles per liter, plus the y-intercept, and I need some units, but they're just whatever the units are on the y-axis. So I've done everything except the units for the slope. Okay, so the units, remember, these are going to be the y units over the x units. So that's going to be percentage divided by moles per liter. We can simplify that as percentage times liters over moles. So we'll write that in here. Percentage times liters over moles. So what I'd like you to do in this video is pause it and see if you can write the mathematical model if I give you the best fit line, because I forgot to write it. So I'm going to go ahead and write it right now for you. Y is 79x plus 1205. So why don't you pause the video and see if you can write the mathematical model, including all of the units. Okay, so go ahead and give that a shot. So now if I know you guys, half of you did not pause the video and try this at your own, so pause the video, give it a try, and then restart the video and I'll do the problem with you. Okay, I'm going to assume that you went ahead and tried it on your own, so let's go ahead and check your work now. Okay, so the y, right, we got y mx plus b. So y is the discharge, talking about a flood here. Okay, in CFS. Okay, those are cubic feet per second, by the way. Equals the slope, which was 79. I'm going to need some units, times the x, which is this recurrence interval, which is in hours, so plus 1205. And remember, the units for the y-intercept are just the units on the y-axis, right? So those are your CFS, cubic feet per second. And then what are my units for my slope? They're the y units, right, over the x units. Okay, so CFS per hour. So you should now be able to, once you've made a graph that appears to be linear, to write the mathematical model. And then once we've written mathematical models, we'll see that we can use them to describe similar situations.